Hi, this video is about learning to do data analysis, and we're going to take a look at three main areas here. What is statistics? The importance of variability as students learn to do data analysis, and finally the main steps in the process of doing statistics. What is statistics? How is it different from mathematics? Well, statistics can be defined as learning from data, where data are numbers in context. So the context plays a very important role, as Van de Waal says. In statistics, the context is essential to analyzing and interpreting the data. So in some sense, if you're not paying attention to the context, you're not really doing statistics. Um, and so we always want to think about, when studying statistics, how do we connect things back to the context? How are these numbers not just numbers, but they're data because they're connected to a context? When students learn about statistics, it's important for them to think about and learn about variability. It plays a very important role in data analysis. When we learn from data, we tend to focus on what we call the central tendencies in the data, the average or the mean in the data, the median. A lot of times you'll hear news reports or things like that talking about average values, but not give as much attention to variability. However, examining variability in data is just as important because the measure of center really gives a limited notion of the data. And very different data sets can have the same measures of center. For example, if we look at this set of data over here, we can see that the center of the data pretty clearly is right in the center of this column. However, here's a very, very different looking set of data that has the same center of the data. The average would turn out to be the same value in both these sets of data, and yet they're very different. It'd be pretty clear in this set of data that we have a lot of values clustered around that center, whereas here it looks like we've got two pretty different clusters of data that are balancing each other out. So the variability can help us understand the differences between these two sets of data when we examine that. How do kids tend to learn about variability? Their understanding tends to follow these two trajectories. The one on the left here breaks it down into six kind of tendencies in student thinking. First, they tend to focus on outliers or extremes. So if we look back at our sets of data here, they might realize that the one on the right has much lower and much higher values as compared to the one on the left. Next, they're able to think about the variability in data over time, and so we can begin to look at how things change over time, and that they can make sense of that. Next, they move on to examining variability as the full range of data, and so that's a useful and a little bit more sophisticated way to think about data. For example, if I'm looking at these two sets of data, the full range here, it looks like we've got a range of 3 on this set of data, whereas from here we go from 0 up to 9. So we've got a full range of 9, and that can help us understand the variability. Next, students consider variability as the likely range or expected value, so they can start to think about what might be expected in certain situations, which is a more sophisticated way to think about variability. Finally, we get two related concepts that can look at how far data points are from the center. So looking once again over here at our two sets of data, if the center is here, they can talk about the data either being right on the center or one off of the center. Whereas here, we have data that ranges many values away from the center, and there's a difference there. And then finally, looking at how far off an entire set of data is from a fixed value, so rather than just single points of data, looking at the whole set. Another trajectory that they tend to follow is students tend to initially think about variability within one group, or that, for example, they could look at this set of data and think about the variability of that, and then they move on to more sophisticated thinking and comparing variability in multiple groups. How does the variability in the left compared to the variability on the right? Finally, they can consider natural versus induced variability, and induced variability comes from experiments when we specifically alter something. We'll continue talking about the process of doing statistics next.